My name is Adrian Cantharubin. I'll be presenting this webinar on tackling petabyte scalability with Synology's hybrid cloud. So let's just take a look at what's on the agenda today. By the end of this webinar, we'll have run through a petabyte scenario, shown you how to build a Synology solution, best practices and errors to avoid, and finally, the most exciting part, show you how to create a Synology hybrid cloud ecosystem, combining Synology servers with C2 object storage to handle warm to cold/archival data. Next. This is just a visual format of the agenda today, and there we go. So let's get into it. So essentially, a petabyte is 1,024 terabytes. It's a huge amount of data. So to visualize a petabyte, it's usually said a HD video file that can run for about 13 years. And if you're American, you're like one. If you take a petabyte and evenly split it among 1 gigabyte USB sticks, those USB sticks could fill 93 American football fields, which is how they measure things over there. So just some industries that are easily creating petabyte levels of data. Before, petabyte was only affecting giant enterprises, but nowadays we're seeing more and more SMBs reaching petabytes and making it important to create a cost-effective solution. So just a little on my background as well. I have a background in pharmaceutical sciences. So today I'm going to be focusing sort of about something I know a lot about, which is research and development in the pharmaceutical sector, and show you exactly how healthcare, higher education, and media and entertainment sort of play into contributing to big data in R&D. So again, this is just a very simplified overview of the drug creation process. We go from creating a disease being discovered, drug research, clinical trials, drug manufacturers, administered, then drug monitoring. Now, drug monitoring and administering can easily create a petabyte of data or multiple petabytes of data. But for today, I want to sort of focus on the research, the clinical trials, and sort of the end, the manufacturing. And the scenario I'm going to show you will be pretty much how data is sort of generated at the start and what it'll look like at the end. So in this scenario, we have a disease X rises in France, a pharma company in Oxford jump straight on the scene. Like most industries, this is a competition. So they'll send an on-site research team to work with a research organization in France, in this case, University of Paris. They'll gather initial data from the disease in the patients, and then they'll send that to the main lab. The main lab will then interact with an imaging studio in Bristol to create 3D renders and interactions between drug and disease. So this is what we're looking at sort of in the internal initial data being created. So that data on the on-site research team is initial patient data, it's PDFs, CSVs, basically a mixture of quantitative and qualitative data that they'll send to the main lab in Oxford. Oxford will correlate this data a little bit more, refine it, then send to Bristol, the data intensive portion, where they'll create high-def 3D renders of the drug or the disease and then run interactions with them together. And if you're wondering what that would look like, basically that. Essentially, it's a 3D model that you can sort of move around and then send another 3D model against and see how they interact. And then from there, you can start developing a therapeutic area. For anyone that's interested, that molecule there is gastrin. It's a hormone that basically controls how much gastric acid your stomach produces. So now let's jump 5 years forward. You can see that on-site research has now started clinical trials, and with them, each patient can create between a couple gigs of data to 100 gigabytes of data. Now, the disparity in this is caused by the amount and type of data collected on each patient. So in clinical trials, we're seeing anywhere between 1,000 to 5,000 patients, and they're not all the same use case. Obviously, there's some that we may be collecting MRI or CT scans for. Hence, the data is escalating, and we don't have a set rate on them. So as you can see, the data stored on-prem is escalating fast. At Oxford, we're collating data from both sides, from both Bristol and Paris, and they're building a pipeline, collecting key data. Making sure this they're not just working on this specific drug; they're working on multiple drugs. But right now there are 250 terabytes. Same thing with the imaging studio in Bristol, they're around 60 terabytes. Next, and finally, we did it. We manufactured Oxford did it. The main labs finally cracked the case and created a suitable drug for disease X and passed this to manufacturer. The on-site team will have easily gathered a petabyte at this point due to the amount of data and due to the amount of data required by regulatory bodies, so will the main lab in Oxford. It's more of a heavy editing and collating and gathering key data process in the main lab. So hence, for each drug, it'll be about 250 terabytes. And if they're working on multiple drugs just for this disease, then we're easily at 1 petabyte for this whole project. And lastly, the imaging studio will have archived key simulation data for research papers or reviews at university. This applies to key data gathered in France as well as the lab in Oxford. So in this scenario, we started with 50 to 100 terabytes, and in the process, we've already ended 2 sites at around 1 petabyte. And just to show you exactly what Bristol, the imaging studio, is sending forward, it's that. Next. So how can Synology help? In this section, I'll show you exactly how we can build a Synology solution that is tailored for this exact scenario. So this is the solution that I think best fits this scenario. And we have a Synology NAS on-prem at each site. So for Paris, we have an SA6400. For the main lab in Oxford, we have the HC6500. And the imaging studio, we've put in an FS6400. With file transfers using Presto and warm-to archival data gathered in C2 object storage. More on these two applications in a bit. So let's run through the solution in Paris. I've gone with the SA6400 because the amount of data we initially begin with will be quite small, but the data that we gathered from clinical trials will easily surpass 200 terabytes, but we just don't know how much we'll end up on. So that being said, a scalable solution like the SA6400 is a lot more optimal than the HC6500. That being said, for RAM, I've put in 128 gigs. Once you pass 200 terabytes on a Synology NAS, we recommend having 64 gigs of RAM as a base limit, but we all understand the dangers of having insufficient RAM. So always spec this higher so that there's no needless complications. And I'm sure you've all noticed, I've highlighted the SSD cache there in red because in this environment, having increased random write performance will not be key. But if you're unsure, you can always run the SSD Advisor, which after monitoring your data usage will provide you with a clear answer on not only if you need the SSD cache, but of how big the SSD cache needs to be. So again, we do not want to rebuild RAID. That is the last thing on our mind. So we don't want any failed drives. So essentially, we have a hot spare that will kick in the moment a drive starts failing and does not need any hands-on maintenance other than replacing the faulty drives. So this is pretty good if there's people involved who are not very tech savvy, meaning that as soon as the drive starts failing, they will not need to do anything as the hot spare will kick in automatically, other than pulling out the faulty drive itself, which can be done sort of later on. And again, we'll be putting a hot spare in sort of every chassis as we go forward. And because we already know that initially the data generated here will surpass 200 terabytes, we can already start building a peta volume. So here's just some errors to avoid. And the first thing is that the peta volume can only run on RAID 6, and to have access to all applications like high availability on the DSM, you would require DSM 7.2. Lastly, and this is just a breakdown of the initial costs. So of course, the cost of the hardware, 27K, cost of support, so installation, and then the cost of energy, we've based that off of us here and the energy uses we provide. So at this point, this is not set in stone because the rates could be better where you are, or it could be less. But again, that's subject change. And finally, the total, we're at a little under 32K, and this includes the Presto license as well, because we're transferring files from here to the main lab in Oxford. Now, you're probably wondering what Presto is. So I mentioned it before, the Paris site and Oxford site, as well as the Bristol site, they're all sort of collating to the main lab, and they're sending all this data from Bristol or from Paris to Oxford. Now, obviously, from Bristol to Oxford, not too bad, but from somewhere from Paris to Oxford, that's an environment with high latency. So that's where Presto is very useful. So Presto is a Synology DSM application designed specifically for these environments. So it's based off of the UDP, and it utilizes Synology Internet Transfer Accelerator to deliver these large files. Now, normally, if you wanted to move this data from Paris to Oxford, you could, take the couple days it would take to transfer the files and just sit there on the network, or you could ship the physical NAS box or the drives themselves. But Presto sort of eliminates that by allowing you to just send the data directly. So a 1 TB file uh, would normally take a couple days to send via network. Using Presto, you can do that in less than 5 hours. Now, we did talk about a peta volume before, and I would just like to point out that Presto cannot run on a peta volume. So in the case of the SA6400 in Paris, what would happen is we would create a separate volume for Presto itself, just for any files that need to be transferred from there to Oxford, would run on that folder. And of course, if that's too much, you can always run an rsync between these folders, so you can always just save to the peta volume, and then it will go down into the normal folder for Presto. So that's just sort of an overview on Presto. Finally, back at the main lab in Oxford, we have the HD6000, and which the reason we went with that is because we know exactly how much data we're going to end up with, and we know the rate of data that we'd intake each year. And because we know we're going to fill the entire storage, we're going to go ahead and also fill the entire RAM as well to 528 gigs. Furthermore, HD 6400, or in Oxford specifically, this is the case where an SD cache will be vital, as this will be a site where we'll need the quick read and writes, which again the HD is perfect for, with around 6,000 in 6.65,000 or 6,500 44 read and 6,837 write throughput. And again, we have sort of a cost breakdown. So initially, this is just under 65K. So like I said before, both the Paris site and the Oxford site have sort of the same role. They're collecting data. Oxford, however, needs to centralize it and keep data for regulatory submissions. And at the end of 5 years, the cost of the solution will look like this. And this total includes the cost of the energy used. And again, we base the energy costs on ourselves. You might have a better rate. This cost also includes the Presto licensing. And just to sort of speak on what would normally occur in these places, that you normally would spend about 20K a year for a rack at a data center. You'd fill it with storage. And to build to 4 PB, you're easily breaking the 200K mark. And a lot of these servers will not have tailor-made OS like the DSM. So you will not be able to transfer files as easily as we can. Finally, the third part, the imaging studio. Now for the solution, the part of the solution that doesn't change from the start. At Bristol, we just need super high performance. So of course, we're going with the FS 6400 with a read-write throughput of 7,000. I understand that when you're looking for the highest performance, you always go RAID 10. It makes sense. But due to how well these Xeon processors are performing, RAID 5 and 6 are doing considerably better. And the benefit of having, that drive tolerance more than makes up for the lessened performance. And RAID F1 is essentially based on RAID 5, but created specifically for an all-flash array. So rather than having all the SSD sort of failing at once, it pushes more workload onto one SSD and then overall increases the lifetime of the storage pool. Furthermore, where for the best performance, we would say, 2 volumes, and in those 2 volumes, have 2 shared folders as a baseline minimum, just so that you're not all sort of going into one volume and one folder, and you're sort of spreading the load essentially. And finally, let's not forget about networking. For this solution, I've chosen the NFS SMB instead of iSCSI because the data is stored in a file format, and this is the best way to optimize Synology syncing and sharing tools like Cloud Sync and Presto. And finally, always make sure you enable jumbo frames at all points, so you don't have any bottlenecks. Either your NAS, the switch connector, and here's sort of a come on. Well, here's a breakdown of the costs. So again, we're looking at 130K of the solution, or below 130K of the solution. So this is the solution that I think best works for this scenario. And normally a large enterprise like Pfizer or Janssen will incorporate the data costs in their huge R&D budgets. But the considerable amount of the pharmaceutical sector is made up of smaller companies who will need to think carefully about how and when to best budget their data costs. So Synology offers a premium performance while also being a cost-effective alternative. And now I promise you I haven't missed it out. C2 object storage. As you can see, I've sort of created a border around it to show exactly that at any point whenever a cloud will be used, C2 object storage is what we're going to be using. And so, like I said at the start, this is the exciting part. Here, I'll show you exactly how you can interact with C2 object storage and create a hybrid NAS ecosystem. So firstly, just putting this in clear. So in the previous scenario, in Paris, Oxford, and Bristol, throughout the whole process, two things were happening. Firstly, any key findings in Paris and Bristol will need to be archived for review. So let's say an interesting case presents itself during the clinical trials, and the team in Paris wants to talk with a friend or an external scientist in Ireland. Rather than giving this person access to the company's NAS, you can send that large data set into C2 object storage and then provide them with a read-only link, allowing them to access the data easily. And this is quite useful for the imaging studio as well, as they're sending a lot of unstructured data. And C2 object storage, like the name suggests, uses object storage rather than block or file, and works easily with Synology NAS using the Cloud Sync application, but can also work without a NAS, and I'll showcase that in a moment. In this scenario, it's about 500 for 500 terabytes for 5 years. The costs are just a little under $175,000. Now, that is just a drop compared to the pricing model set up elsewhere, where you can see that for 1 terabyte a year, you're charged almost 20 times with others. So, this is a demo of C2 object storage, and I'll be showcasing exactly how this works without a Synology NAS. So using a Synology NAS, you'd set up Cloud Sync to sync up your folders from there to C2 object storage, and it's done pretty much through a couple clicks. Whereas, let's say you have access to C2 object storage, but you just want to map a drive. This is where I'll show you how you can use an S3 compatible application like S3 Drive and C2 object storage. So this is the interface. I've created my bucket already, calling it Pharma bucket. And here you can upload folder and file. So at folder level, it will just show you the folders. If you click into the folder, it won't show you the files specifically there. And that's because we have the upload the file option. There, farm project, do not delete, happily named. So now we want to interact with something like S3 drive. What we need is first, we need to create the access key for this bucket. Now, when you create the access key, you can do it now, or you can do it when you created the bucket, essentially. To the farmer bucket, and you can see there it says choose the access type for this access key, and it's read and write. So when I'm interacting with S3 drive, I want so let's say I'm a scientist and I have the map drive and I want to put folders on there. If it's just read only, then all I can do is read from that file. But if I wanted to put it on, then put read and write, which makes it simpler for me rather than going to the admin and asking to put it on C2 object storage. So here's the access key. We'll download those keys. And again, it's just a very simple notepad. We have a secret key and an access key. Now we open up S3 Drive. It's new. Go down to C2 Object Storage and drive name, put Pharma. Fill in the access key from our handy thing. Yep. And this will, so the reason I picked S3 Drive is because A, it's free, and B, it's very easy to use, which and just any S3 compatible will be able to work with C2 object storage. And you can see that it already found my bucket. You can test the connection, but just go straight and bam, there it is. We created a map drive, and just to show you sort of how simple it is, like how simple it is to use when When copying a folder, we'll go to the farm project folder and just transfer that file across. Now you can see here I clicked and dragged, but it creates a copy rather than just moving the file over directly. Now you won't lose the file. It means you won't lose the file if it's a copy, but also when it goes into the bucket itself, you'll find that using versioning and object lock, it becomes very hard to delete the file in question. So with versioning, you can go back to times when there was any modification. So if we go in buckets and farm bucket, you'll see that farm project, which was empty before, and now it's there. And again, this is object storage. So it's relatively new. There are a lot more things coming out in C2 object storage, like tiering, but that's sort of for another presentation. So now, oh, start it again. Next. So just to recap, going through this webinar, we've understood the petabyte space, looking at a use case in the healthcare industry, gone through best practices, errors to avoid, key insights to optimize the cost of solution and streamline its implementation, and C2 object storage showed you sort of exactly how C2 object storage works with a NAS and without a NAS to provide you with the optimal solution. So that's the webinar. Thank you guys for turning up. Thank you guys for listening.